My name's Teresa, and today I want to talk about human performance and safety at work. For a long time, we've talked about zero. Zero incidents, zero accidents. Basically, zero mistakes. The concept of zero errors sounds really good, and it's what we all strive for. But it's impossible. We're all real people. We're real, resilient people, and we all make mistakes. And we all work as part of systems with other people, tools like computers, and with procedures and policies and rules. These systems are supposed to be safe. And sometimes managers can think that the system is perfect, if only the workers wouldn't mess it up. And sometimes the workers think the system's broken, but that managers just don't care to fix it. But the truth is that the system will always be flawed, and workers and managers need to work together to help make it safer and better for everyone. So let's figure out how. First, we need to understand, why do people make mistakes, and how do accidents happen? For this, I'm going to talk about 4 models of failure. The first is chain of events. The idea here is that events are linked, and failure happens at the weakest link. To avoid incidents, the weakest link needs to be removed or strengthened. Here is a hierarchy of controls to show us how we fix this link. The hierarchy of controls suggests that to prevent failure, it's better to first eliminate the weak link, and if you can't do that, then substitute it out. If you can't do that, engineer it out. Then maybe an administrative or procedural control. And finally, the last line of defense is personal protective equipment. In this model, if a weak link is strengthened, the incident is avoided. The second model is the barrier model. This suggests that layers of protection exist and that incidents happen when holes in the barriers line up. To avoid incidents, we need to keep our barriers healthy, and things like function testing of valves or inspecting for corrosion can tell us if our barriers are deteriorating, and we can take action to fix them. The third model of failure is called systems failure. This is the idea that complex systems have latent defects that are incredibly difficult to predict and prevent. Especially when physical systems, technology, and human interfaces come together, we get these complex systems. Finding and eliminating latent defects before they bite us is critical, and it's hard. It often involves structured risk assessments, where diverse groups of people who each know a lot about individual components come together in a HAZOP or operational risk assessment to look at the system piece by piece to spot and squash the hazards. And by doing that, they stop the incident. The final failure model is drift. This is where we start off on the right path or the safe route, and inch by inch we drift off course. Drift is caused by the most human of tendencies. It's when we want to do something faster, or when we've done it that way in the past and gotten away with it. Sometimes we're trying to do what we think the boss wants, something that'll get the job done faster, better, or cheaper instead of safer. Drift can be corrected so we can stay on a safe course. Things like audits challenge us to demonstrate that we're taking all of the right steps at the right level of thoroughness or quality. Visible leaders who go out with a real interest in their people and how they work, to understand and to ask how the work is done and to learn about safety in their organization, will have conversations with different workers that will actually help workers understand that safety really is important to them. Supervisors reinforcing the use of procedures and attention to detail and safe work can remove the time pressure or the efficiency wiring we all seem to trend to, especially on repeat tasks. These failure models help us understand why certain systems exist, things like audits or inspections and other controls, and they help us understand how our tools can prevent incidents. Human performance is a fundamental understanding that we all make mistakes and that our systems are not perfect. But through curiosity, listening, and ultimately by learning is how we can predict, prevent, and manage error in an imperfect world.